Welcome to our channel. Today we're diving into the fascinating world of time. But what exactly time? How do we measure it? And why does it sometimes feel like it's slipping away from us? We'll explore everything from time dilation to the possibility of time travel. So, buckle up and prepare for a journey through the very fabric of time itself. Einstein's theory of relativity tells us that time is not the constant we think it is. Imagine you have a twin and you send them on a spaceship at near the speed of light. When they return, they'll have aged less than you. That's because time actually slows down the closer you get to the speed of light or a massive object like a black hole. Gravity warps the fabric of space-time, and this warping affects the flow of time. The stronger the gravity, the slower time moves. Ever wonder why we have leap years? It's because the Earth doesn't orbit the Sun in exactly 365 days. It takes a little over 365.24 days, hence the extra day every 4 years. But did you know we also sometimes add a leap second to our clocks? Earth's rotation isn't perfectly consistent. To keep our clocks synchronized with the Earth's spin, we occasionally add a second, usually on June 30th or December 31st. Since leap seconds were introduced in 1972, we've added 27 of them. We humans have come a long way in our quest to measure time accurately. From sundials to hourglasses to mechanical clocks, the most precise timekeepers we have today are atomic clocks. These marvels of engineering utilize the incredibly regular vibrations of atoms to keep time. Cesium atoms in particular are used in atomic clocks because their vibrations are incredibly stable and predictable. By counting these vibrations, scientists can measure time with astonishing accuracy. Atomic clocks are essential for a wide range of applications, from scientific research to global navigation systems. We've all heard the phrases, "time flies when you're having fun," and "a watch pot never boils." Our perception of time is not fixed. It's fluid and can be influenced by a variety of factors. When we're engaged in enjoyable activities or experiencing heightened emotions, our brains tend to process time differently. Conversely, when we're bored or anxious, time seems to drag on endlessly. Think about how differently time seems to flow for a child compared to an adult. Understanding how our brains perceive time can help us appreciate the present moment and make the most of our time. Time marches on, relentlessly moving from the past to the future. This unidirectional flow of time is known as the arrow of time. One theory is that the arrow of time is linked to the concept of entropy. The second law of thermodynamics states that entropy always increases over time in a closed system. Some scientists believe that the universe started in a state of low entropy, and the arrow of time is simply the universe moving towards a state of higher entropy. It's a fascinating concept that has puzzled physicists for centuries. Time travel has been a staple of science fiction for decades, but could it be a real possibility? One theory involves wormholes, hypothetical tunnels that connect different points in space-time. If wormholes exist, and we could figure out how to manipulate them, we might be able to travel through time. Another possibility is time dilation. If we could travel at speeds approaching the speed of light, time would slow down for us relative to someone on Earth. This could potentially allow us to travel far into the future. Have you ever noticed how your body seems to know when it's time to sleep, eat, or wake up? That's because we all have internal timekeepers known as biological clocks or circadian rhythms. The most well-known biological clock is the circadian rhythm, which governs our sleep-wake cycle, hormone release, body temperature, and other bodily functions. This internal clock is synchronized with the 24-hour day-night cycle, primarily through exposure to sunlight. But our bodies also have other biological clocks that operate on different timescales. Understanding how our biological clocks work is crucial for maintaining our health and well-being. Let's dive back into Einstein's theory of relativity with another mind-bending thought experiment: the twin paradox. Imagine you have an identical twin. You stay on Earth while your twin boards a spaceship and travels at a significant fraction of the speed of light to a distant star and back. According to Einstein's theory of special relativity, time slows down for objects moving at high speeds relative to a stationary observer. So, when your twin returns to Earth, they will have aged less than you. The twin paradox highlights the strange and counterintuitive nature of time and how it is relative to the observer's frame of reference. Before the invention of the telegraph and railroads in the 19th century, each town set its clocks based on the local solar time. This meant that noon in one town could be several minutes different from noon in a town just a few miles away. With the advent of long-distance travel and communication, this system became increasingly impractical. To address this issue, time zones were introduced in the late 19th century. While time zones have made our lives more convenient, they also illustrate how arbitrary our measurement of time can be. Time, as we know it, has a beginning, the Big Bang. But will it ever end? Cosmologists have proposed several theories about the ultimate fate of the universe. One possibility is the Big Crunch scenario, where the expansion of the universe eventually reverses and everything collapses back in on itself. Another possibility is the Big Freeze, where the universe continues to expand indefinitely, becoming increasingly cold, dark and empty. And then there's the more speculative idea of a Big Rip, where the expansion of the universe accelerates at an ever-increasing rate, eventually tearing apart galaxies, stars, planets and even atoms themselves. While the ultimate fate of the universe remains a mystery, contemplating the end of time challenges our understanding of its nature. Thanks for watching. If you enjoyed these mind-blowing facts about time, don't forget to like, subscribe, and hit the bell icon for more amazing content. We've explored the strange and wonderful world of time, from the cosmic scale of black holes and expanding universes to the personal experience of how our brains perceive time. While we may never fully unravel all of its mysteries, continuing to explore and learn about time deepens our appreciation for its wonder and the preciousness of each passing moment. See you next time.